A solution is a homogeneous mixture of one or more solutes dissolved in a solvent. A solvent is the substance in which a solute dissolves to produce a homogeneous mixture. A solute is the substance that dissolves in a solvent to produce a homogeneous mixture. Key steps to making a solution. First, calculate the weight of chemical needed to make 100 milliliters of solution using the above formula. Then, weigh out the amount of chemical needed using a balance. Then, transfer the weighed out chemical to a volumetric flask with 100 milliliters of distilled water. Then, gently swirl the flask until all of the chemical is dissolved. What is a dilution? A dilution is the process of reducing the concentration of solute in a solution. Key steps to making a dilution. Use the formula molarity 1 times volume 1 equals molarity 2 times volume 2 to calculate the amount of stock solution needed for the dilution. Then subtract the amount calculated from 100 milliliters to find out how much deionized water to add to the stock solution. Then combine the two in a graduated cylinder in order to create a new diluted solution with a new desired molarity. One tip for getting good data when you have to make a dilution is making sure that you're not trying to use a stock solution that is too small. For example, when making something like a 0.001 molarity solution from a 1 molar solution, it's better to make a larger amount, for example, making 100 milliliters of something, rather if you only need 10 milliliters, because you don't want to try and measure some tiny, minuscule amount of stock solution and make an error. You'd rather make a larger solution and get a correct reading and then use from that the amount you actually need when performing any experiment that you need the diluted solution for. Of course, to achieve good data, you should follow proper lab procedures, such as making sure that all your materials are clean of any excess chemicals or unneeded chemicals from other prior experiments. You should also, when using the weighboat, make sure you're definitely zeroing out the weighboat when measuring the mass of the chemical you're using. You should make sure that if you have to crush if your chemical is pellets and you need to crush it, make sure you're forming a very fine powder in order to fully dissolve it in the deionized water. Here are just a few sample calculations for various dilutions that may have to be done, going from an initial molarity of 1 to various molarities of 0.5, 0.1, 0.05, 0.01, and 0.001. First, you can see that using a balance and weighboat, we are measuring out some of the chemical. The chemical we used for this solution is actually more of a pellet, so it needed to be ground in order to make a solution first. So if you notice, there's first some excess product which was obtained, which allows the excess chemical obtained allows any minimal mass loss when grinding up the chemical to be accounted for. So we then made sure that when we were measuring the final ground product, we measured out precisely 15.96 grams, which is what our calculations calculated was the desired amount of copper 2 sulfate, which is the chemical we were using. We then added this to 100 milliliters of water, and as you can see, we swirled it in the volumetric flask in order to create our solution. Now you can see, measuring out the deionized water, that will be needed to add to the small amount of stock solution that will be diluted out using the water. The water was then added to the stock solution in the graduated cylinder, which then created the dilute solution. This is then repeated for any other dilutions that need to be performed. And then, as you can see with our final dilutions, the various shades of of liquid created. This is because we used a colored solute, which allows to see the actual dilution. This may not always be the case. That's all for today, folks, so let's go ahead and stop there.